modal, but that's definitely the most. After try, we're like, screw it, there's no mode. If there's like 4 things that occur 5 times, there's no mode. And it kind of makes sense. So what's the mode? What's this idea? And by the way, I did say this works with qualitative data. So a real quick example would be, if you go out to the parking lot and you see 40 Hyundais, I just like to say Hyundai, 30 Toyotas, and 2 BMWs. What was the mode? Hyundai's good. It's not quantitative data. Hyundai. I sit in my Hyundai and eat Cool Whip. No, yes. If you don't get that reference, like, Cool Whip, what the shit? That's how he does in this Hyundai. All right. So it works with both types of data. It's the one way to get a center, measure for center. It's trying to see where does data cluster. Where's data clustering? So that's why once you have more than 3 places, it really isn't clustering anywhere. It's still too spread out. Okay, maybe. Okay. And then there's one last one that I don't think the book even talks about. It's not going to stop me. And it's called the mid-range. And what's the range? Anybody remember what the range is? High minus low, I love it. So the mid range should be the number that's in the middle of the range. It's crazy. So what sucks is if I have like this, what's the range of this data? 14. How do I find the mid-range? So this was high minus low, right? How do I find the middle of these two? What do I do to find the middle of any 2 numbers? How do I find the middle of any 2 numbers? You take the average. And what does average involve? Adding. So what sucks for people is mid-range. Range is subtracting because you want to see how far apart these are. Mid-range is freaking adding, then cutting it in half, of course, right? Because it's finding an average. That freaks people out. So what is this? 17, please. Yes?
Where'd you get the 2 from? Is it just
2? Oh. How do I take the average? And here I'm taking the average of 2 things. So that's why I'm dividing by 2.
Oh, okay.
If I want to find the middle of any 2 numbers, I take the average. So I'm always going to divide by 2, which is 2 numbers. Yes?
So why do you add the 2 numbers?
Because how do I find the middle of any 2 numbers? How do I find what's in the middle of any 2 numbers? I take their average. So all I'm doing then is finding the average of the high and the low. That's why there's a plus in the mid-range, but there's a minus in the range because the minus wants to know how far that is and what's distance, subtraction. Okay, maybe. But people always get that freaked out. The brain goes range and put a minus everywhere. It's like, shit. Okay. All right. I think that's it for center. So now I want to devote the rest of the time to talking about spread. Somebody got this here? Okay. So, let me ask you guys. Let's see. You do it, Jeff. So I'll tell you this, from that section involving measures of center, the one that won, you already kind of know which one won. What do we talk about the most out of those measures of center? Huh? The mean, yes. In fact, some of you guys had never heard of the median before, the mode, all that's in the mid-range for sure. So the mean seems to have won. It doesn't mean it's always the best, but it's what we're going to use almost all the time, is the mean. It kind of won that game. So it's only when there's extreme outliers you got to be careful. Okay, maybe. So, can somebody tell me very quickly what the mean of each of these three sets of data is? Well, let me say this. You guys should be. Really, Jeff? Did you leave all your markers somewhere else again? You're awesome. All right. I'm going to say these are each populations, believe it or not. Okay? All three of these are populations. Population doesn't mean big. It just means the whole group of things you want to say something about, right? Doesn't have to be big. It normally is. Here it ain't. I'll do this one. The average of this one is 5. Yes. Yeah, all of them's 5. And again, why is it? Do you guys see what I did to make it always come out to be 5? If 5 numbers average to be 5, they have to add to be what? 25. So if I make this one go down by 1 and this one go up by 1, it still adds 25. It's still going to have an average of 5, right? So all of these have an average of 5. So does the mean distinguish between these three groups of data? Because would you say they're all the same? No. You with me? Okay. So I need something else to distinguish these three groups of data. And before you tell me the range, because is the range the same for all three? What's the range here? What's the range? What's the highest number? Minus the lowest number. Okay. What about this? What's the range? 2. And what's the range here? 4. How about this one? What's the range there? 4. What's the mean? Still 5. Does everybody see I just made that go down by 1 and that went up by 1? So the mean is still 5. They still add to be 25. Let me slow down for a second. I just want to make sure you understand the range ain't good enough either. Would you say these two data sets are the same? No, but the mean is the same for each, and the range is the same for each. So there's got to be something else. What is the fundamental difference between these two things? So if the mean is the center, what should spread mean? What should the idea of spread indicate? Yes? Between what? No, because that's the range, and the range we already saw I have to throw out as a candidate because it doesn't distinguish between these two. So we can do this. If there's an asteroid impact, and I want to see how big, how much devastation there is, how far away, I'm going to measure whether the crater is away from the center, right? How far from the center did the crater get? How much did it destroy? How far away from the center? All right, I just came up with that. I don't know if that's really great, but what I'm trying to say is, spread kind of makes sense that it's a measure of how far away from the center the data points get on average. Let me say that again. The spread of data should be how far away on average the data points get from the center. And what center are we normally using? Mean. I love you guys. You're all looking at me like, but I just want to make sure you understand what I just said. Does that make some sense? So, which one of these has the lowest spread? I mean, first one, it doesn't get away from its center at frickin' all. This one gets away from its center a little more. This one gets away from its center a little more. And then this guy should be the most. He's got more data points further away from the center. So whatever the hell, this is so cool to me. And I know for you guys, it's going to be like watching hot dogs get made. But We're going to create the formula and make it tell us what we want it to tell us. That's what math really is. I want to know this. You make you tell me. So we're going to construct this thing, and you're all like, this guy's abusing math. Get that math away from me. Sorry. We need MPS, Math Protective Services. Sorry. All right. I really kind of want you guys with me on this. You don't get to see this very often, constructing a formula. This is how a lot of math kind of works. Statistics is a little different, like y equals mx plus b. Couldn't really have been any other way. We could have used different letters, but that to represent a line, it's got to be something like that. There's actually a few different, and I'm going to talk about them as we go through, different choices to make for this. I'll try to explain a little bit about why we made the certain choices. But let's write down our data. Let's do this one. Let's do these two. Yeah. 3, 4, 5, 6, 7. Put that down. Now let me say the kind of the idea again. Whatever this thing is, if it measures spread, it should tell me how far away do all the data points get from the mean on average. What's the average distance from the mean to the data points? Really sink that in. Really think about it. What's the average distance from the middle to each data point? That should tell me how spread out the data is. It's going to be one number that tells me how spread out the data is. So let's break that down. How do I find the average anything? Yeah, so if I wanted the average age in here, I love it. Here I'm on. How do I find the average age on here? I have to first make a list of ages. Right? If I want to find the average shoe size, I got to first make a list of shoe sizes. Maybe left foot shoe size, right? Because some of us have different size feet. Right? All right. So if I want to find the average distance from the mean to the data points, I have to first make a list of distances from the mean to the data points. Right? So the very first thing I'm going to do is this data point. How far away from the mean is it? Oops. That says population. I want to make a list of how far each data point is from the mean. Now, some of you guys might notice it's going to come out negative. So like negative means they are below the mean. Right, but that is an issue that we're going to have to take care of. Do you guys see why I'm doing this? I really want this to make some sense, because the more these make sense as to why we do them, the easier they will be to do. It just is. So the mean again, what was the mean? The sum of these was 25. The mean was 5. So here it's going to be 3 minus 5. Negative 2. And then this will be 4 minus 5. 5 minus 5. 6 minus 5. 7 minus 5. So I got a list now of all the distances. It's not really truly distance yet. In fact, if I try to average these, what will I get? What do they add up to be? 0. In fact, think about it. Anytime I make a list of data points minus the mean, they're going to add to be 0, because the mean is the middle of all the values. So you're going to have an equal amount negative as you do positive. So they'll always kill each other. Way to go, Jeff. You got 0 all the time. Shit. So the first option we're going to discard, but we'll talk about it right now, is this. How do I do distance in mathematics for real? Real distance, so it doesn't come out negative. What always makes things positive? Absolute value. Right? You guys remember that? Absolute value always comes out positive. Why? Because it's based on the idea of distance. So what's the absolute value of negative 7? 7. What's the absolute value of 7? 7. Good. Very single-minded, make it positive, right? What sucks about this? Does anybody know what that looks like if you graph it? Has anybody ever graphed an absolute value function? Anybody remember or know? What's a squared function look like? X squared. There you go. I got somebody painting me a picture. Parabola. That's right. No, it's parabola. Don't listen to me. Not then, anyway. Most of the other time. Yeah, parabola, right? An absolute value. And why does it turn like this? Because when you square a real number, it can't come out. When you square a real number, it can't come out negative. So it goes to 0 and it goes, oh shit, and again it turns. What can an absolute value not come out to be? Negative either. So, but it's going to be a straight line because absolute value of x is not curved. So why is x squared curved? Because it's squared. When I have a first power, it's a line. So absolute value of x is going to look like this. What's the absolute value of 1? 1. What's the absolute value of negative 1? Negative 1. What's the absolute value of 0? 0. What's the absolute value of 2? 2. What's the absolute value of negative? Negative 2. Bam! I really want this to make sense out. Mathematically, does that have a bad problem spot? If that was a plane flying, a flight path for a plane, do you want to be in that plane? Do you understand what would happen right here? You would be dead. You would be mush. You would be gross. I would basically just trash the plane and give up on it. I wouldn't try to. I have this morbid thing today. It's too bad, right? But we'd all be dead because it would, boom, you just instantly change position. You're all squished up against the other side of the plane. Now, that's physically a problem, right? You don't want to be in that plane. Mathematically, it's a problem because it's a sudden turn in slope. What's the slope here? Negative 1. What's the slope now? 1. So there are deeper meanings behind why we choose not to do the absolute value. That sort of teases out some of those problems. So what do we use instead to make it positive? We use square. We square it. Because what's the fundamental problem here? There are some negatives. I could use absolute value. I try to give you a little taste of why we don't. What can we do instead to make it always come out positive? Square. Which means what will we have to do at the end? Square root. Because this is like number of pets people own. And that's square it? Well, that's square dogs and square cats. And like, shit, I don't want to see that. No, it's just for me. Like little Picasso dogs and stuff. All right. So instead of doing absolute value, we're going to throw that out. We're going to just square these things. So then we're going to get 4, 1, 0, 1, 4. Now if I add those up and divide by how many there are, I will get the average squared distance from the mean. And then I do what to it, of course, like you just said. Square root it. And then I get what I want. I want that measure of spread. Really? So I took the difference to see how far away the data points are from the mean. I want to average them, but right now I'm always going to get 0 here. That's crazy. Kill the negatives by squaring. Then get an average and then square root at the end to kill the squaring we had to do. Yes?
Could you just go over again how you got the last row?
Yeah, square these.
Oh, okay.
Yeah, this is square these. And where are these? Here. I love it. We're going to be doing this construction of tables a decent amount in here. So what I'm about to do now is I want this spread. Let me give you the symbol for it. All right, did I use the symbol already here? No. It's a fat R. It looks like start at its belly. Start like at its here. Make the belly go around and make the hat. Depending on my mood, they're skinny or they're fat. Okay, don't just make it an R. Really try to write in the language of statistics. I love you guys. So let me do it one more time. So start at the top of the belly. Make the belly go around. That's it.
And what does that stand for?
This is actually lowercase sigma. And so that's just the letter it is. And this stands for the spread, which is called Standard deviation. What's deviation mean? To deviate. Not deviant. Deviate. Anybody know what the word deviate means? If you deviate from your course,
Go on.
yeah, so how far off you are. So deviation is like how far from the mean I am. Standard deviation is sort of like the average deviation. But this isn't totally an average because I had the square in the middle. Do you see what I'm saying? So we have the standard deviation. So again, the math people being creative geniuses, they're like, standard's S. We use sigma. Lowercase. Oh shit, yeah. So we use lowercase sigma, the Greek letter S, for standard deviation. To remind us that we haven't square rooted yet, we put a square on it. So the squared deviation. I really want you guys. So again, I'm not going away from the idea at all. How do I get this spread number? I take the sum of the squared distances divided by how many there are. There's going to be an average squared distance. And then what do I do? The last step, square root. And that's why I put a little square here so I remember, oh, I haven't square rooted yet. So look, if I ever see in a formula, add these up divided by how many there are, that's an average this. Because that's the definition of average. So what goes on the top? Where's that number going to come from? This whole top is going to get replaced with one number. What's it mean? Cover up the summation symbol. Those, do I have those?
Yes.
Yes. And then what do I want to do those? What's that symbol mean? Sum, add them up, add these. What do I get when I add these? 10. Kick ass. So the sum of these is 10. So wherever I see this, I'm going to put a 10. So this is where algebra got you really used to plugging shit in for individual letters. But now this is a bigger idea. This whole freaking thing is 10. Why can't I put something in for x? Because what is x? X is all these freaking things. I can't, so it's 3 and 4 and 5 and 6 and 7 all at the same time. You can't put that in there. So this whole thing, I know what the sum of these is because I made these and I added them up. And what goes on the bottom? What was that? Yeah, in this case, 5 things. Yeah. So that's this. This guy has a name, believe it or not. Before I take a square root, it's called the variance. That's exciting. That name kind of makes sense. The variance. How much does it vary? Right now, it don't mean shit except we haven't square rooted yet. Later this semester, we might see a little bit more about what it means. But how do I get the number I really want, the spread number? I take, and this is 2 obviously, so then I take the, how do I get sigma by itself? Let's take the square root to kill that dude, right? What's the square root of 2? Yeah, okay. 1.414. Math people, we got that shit memorized. The square root of 2. Don't memorize it, you're fine. So if I were to do everything we just did for this set of data, should the number at the end be bigger or smaller than 1.414? What did we say about these? Who's spread out more? Who gets away from its center more? D does. So if I do all this stuff, its sigma better come out a little bigger than 1.414 to show that it is more spread out, which is the range doesn't do that. It doesn't distinguish between the two. So real quick, you don't even have to write this stuff down. If I did all this stuff for 3, 3, 5, 7, 7, these would have been 2s, right? 3 minus 5, 7 minus 5. This would have been 4, 4. Already I can see it's going to be bigger, right? 4, 4, 4, 4, that's 16. 2, that's easy. 2. And then the square root of 16/5, I don't know what the hell that is. It would be like 4 over square root of 5. 4. Nobody's going to help me. All right. Nobody's going to help me at all. They're just going to watch me. 2.2.
1.79.
What is it?
1.79.
1.7. Thank you. 1.7. Keep going. 9.
Around.
Don't round.
8.8.
8.8.
4.384.
8.84. 8.8.
There's another 8.
Another 8.
Want me to keep going?
No. So we're always going to round this number to 3, at least 3 decimal places. We're going to round standard deviation to at least 3 decimal places. Notice I said at least. We're going to later round probabilities to 4 decimal places. So if you just round everything to 4 decimal places, you'll be covered. You see how that works? Maybe? If you don't want to, it's okay. Just try to make it easier to follow my weird-ass rules. The reason I do that is we're going to use standard deviation in formulas, and the less you round, the better. So, I'm going to finally shut the hell up. I'm going to let you guys try this out. I've got a little handout. It's got an example on one side, completely worked out, with all the kind of questions I normally would ask. And on the back is all the same questions, but with different data. So you guys get to try that out. Let me give all these out, and then if you need a calculator, you can come up here. But don't you have to come up here yet. I lost track. Shit. So I want you to work on the side that isn't done yet. Let me do this real quick. Who needs to borrow a calculator? And then I want to show you how to do some of this in your calculator. Yeah, block that bad boy. Show you. This will come in really handy when you have a larger set of data. There it is. Okay. So look at the example side real quick. The one that's all worked out. Can you take a minute? You guys remember how to get to your lists? You did the sorting the other day. Put the data from the worked out example. Yeah, the 1, 2, 5, 8, 9. Put that data into the first list. Oh, it's still going. Good. Keep on going, little dude. Oh, that would help. Yikes. Let me catch up to you guys. 1, 2, 5, 8, 9. Bam. It's the worked out example. The worked out example. The data. Yeah, I love you guys. I love you guys. Special place for. Okay. So if you go to, now watch. This is how, these are just tables. I want L2, I put it on this just to be really nice. I want L2 to be all L1 minus the mean. The mean in this case is 5. I just average those together. You guys with me? On your side, you're going to have to figure out the hell the mean is first. Notice how I say do not round. Rah. Don't worry, it goes out to one decimal place. Don't freak out. I want to go to L2. I want to define what this whole freaking list is. I want everything in this list to be all the stuff in L1. Here's where L1 is, right above 1. You guys with me? I want L2. Notice how L2 is highlighted. L2 equals L1 minus 5. Bam. And that's the same shit we got here, right? It's just the calculator doing those calculations for you all at once. It's sort of like Excel, just worse. If you've ever used Excel before. If you've never used Excel before, then that doesn't really make sense. So it's like this. And now what do I want L3 to be? I want to take the stuff in L2 and square it, like we did up on the board. So I want to square L2. L2 squared. That's what I want L3 to be. Now watch this. Let me purposefully make a mistake. Is anybody getting this error? If you get this error, it means you try to put a whole list into one spot. The poor little calculator's like, ah. So don't do that. I want to make the whole list L2 squared. All right.
Let's just square button.
Oh, the square button's right there.
Oh,
You could also do 2 to the second power, but there's a little shortcut there. Yes?
Where would you like addition of logos at once?
Yes. Let me do that next. You ready? And then I've got to show you something else that I always forget. So everybody quit. Get the hell out of the list. Say second mode to quit. Quit is very useful. You ever in some table or some list of shit, and you're like, I don't know what this is. It's second quit. It'll get you back to home screen. Now, look above where it says stats. See where it says list? What do I want to do right now? I want to take everything in L3 and I want to add it up. Right? Okay. So if we go to second stat, go to list. I want to do some math on a list. I want to sum up list 3. So go to math. And then you can see which one. Good old number 5. You can just hit number 5. Bam! And notice how it's sort of asking you a question. Sum what? Sum L3. And there's your 50. Now the smaller the list of data, the less you have to do this in the calculator. The bigger the list of data, the more you want to just make the calculator do all that freaking work for you. Right? So your list of data that you have to work with is a little bit bigger. Now, one other thing that I always, without fail, forget before I give out this this worksheet. It's amazing. I'm never going to remember this. What we did up here was the standard deviation for a population.